Viruses make us sick. They're the bad guys. They make us cough and sneeze and leak and even die. But what if we could redirect this killing power and aim it at something much worse, like cancer? Well, my project looks at doing exactly that. Viruses are essentially tiny packets of DNA wrapped up in a protein shell. You crack one open and you'll find all the instructions necessary to make as many as more as you like from scratch. What's lacking, however, are the right building blocks and the right tools. Luckily, our cells have both. And with enough persuasion and trickery from the incoming viral invaders, our cells can be convinced to shut off their regular business in exchange for a non-stop viral production line. The cell is then overworked until it essentially falls apart and dies. But with a little molecular tweaking, we can redirect this. No, I'm just sorry. Yeah, if that's okay.
Yeah, absolutely. We'll start again.
Yeah, sorry.
No worries.
That was just your practice run?
Yeah.
Going fast.
You're going first. It's like that.
Alright. Viruses make us sick. They're the bad guys. They make us cough and sneeze and leak and even die. But what if we could retarget this killing power and aim it at something much worse, like cancer? Well, my project looks at doing exactly that. Viruses are essentially tiny packets of DNA wrapped up in a protein shell. Crack one open and you'll find all the instructions necessary to make as many more as you like from scratch. What's missing, however, are the right building blocks and the right tools. But our cells have both. And with a little persuasion and trickery, the incoming viral invaders convince the cells to switch out their normal business for a non-stop viral production line. With a little molecular tweaking, however, we can harness this killing power for good. So cancer forms when some cells within our bodies acquire mutations that allow them to divide and control uncontrollably. These form tumours, balls of cells, which can jam up important organs and stop them from working properly. The key to making virus treatment work is finding ways to exploit the differences between healthy cells and cancer cells. Paradoxically, this often means making the viruses a little bit worse at their jobs. See, viruses are normally so slick at entering cells and doing their business before the cells even know they're there. Think of a sneaky cat burglar slipping into a house at night and swiping your jewellery. But by chopping out important genes, we can make these viruses a lot sloppier. Imagine that same cat burglar trying it on after half a bottle of vodka. It's smashing lamps and waking the neighbours. It just doesn't work as well. But cancer cells, they don't mind because they're so engrossed in their quest to divide and invade that they stop paying attention to things like viruses. These cells are a bit more like all-night raves. They, even if the virus is drunkenly stumbling in, knocking over lamps, it can still do its business and make off with the TV without anyone noticing. So my project focuses on looking at how is the death of the cell important. So our bodies can recognize cancer and help fight against it, but only if it knows it's there. For example, if a cell chooses to slowly shrink, shrivel up and die, then our immune system doesn't bat an eyelid. This is called apoptosis. However, if the cell chooses to swell and burst, spewing its insides all over the place, then our immune system kicks into gear. This is known as necrosis. So the theory is that by causing this messy and more necrotic form of cell death, we can increase the amount of immune system activation and the amount of cancer killing. So far, I've been playing around with one of these virus genes, and I've shown that by deleting just 3 DNA bases out of 152,000, you can completely change the way that the virus interacts with the cell. Hopefully, I'll be able to show that this new virus induces a more immunogenic form of cell death.